Every single night, while most of us are asleep, there's this invisible workforce that just gets to it. We're talking millions of automated jobs, processing our data, running reports, and basically keeping our digital world spinning. But what happens when these critical, unseen workers trip up in the dark? Well, today, we're going to give them some night vision. We are turning these mysterious black boxes into transparent glass.
Seriously, just think about that for a second. Every night, when everything's quiet, these enormous amounts of data are being crunched, transformed, and shipped around. It could be financial reports, inventory updates. These automated jobs are the silent engines of our digital lives. But what's actually going on in there?
All right, let's take a classic example, a super important nightly job that processes millions of customer records. For a lot of engineering teams, this job is a total black box. They know it starts, and they just hope it finishes. If it fails, it's all hands on deck panic, but they have no clue why or how it's failing until it's way too late.
Okay, so to really get our heads around this, let's think about it like this. This batch job, which is really just a program that runs on a schedule, no humans needed, it's like a silent, automated factory. Raw data goes in one end, and a finished product, say an updated report, comes out the other. But here's the catch. The factory has no windows. None. We can't see what's happening on the assembly line.
So what's the fix? Well, it's pretty simple, really. We need to shine a light inside that factory. We've got to install some cameras, some sensors, some monitors, so we can understand the whole process, from start to finish. And in the software world, we have a name for this: observability.
And look, this is a really important distinction. Observability isn't just knowing if the job passed or failed. That's kind of like just knowing if the factory's main power switch is flipped to on or off. It's about understanding the internal state of the system by looking at what it puts out. It's about knowing, how smoothly that assembly line is actually running.
Okay, so our first step in building out all this visibility is to check the factory's overall health. Its vital signs. This is our first very pattern for observability, and it's all about getting that big picture view. So, we start by asking some pretty basic but super important questions, like how long did the whole thing take? Was it faster or slower than usual? How many products, or in our case records, did it actually process? And what was the success rate for all of them? These are our high-level health checks.
Now this is where you really have to put on your senior architect hat. See, it's not just about collecting the data. It's about defining what's normal versus what's an actual crisis. A job taking, say, 35 minutes might be fine, but if it hits 45 minutes, boom, an alert goes off. Processing 950,000 records instead of the usual million, that's a huge red flag that something is seriously broken.
And that just perfectly sums up why this first pattern is so critical. Before we can start zooming in on tiny little defects, we have to get a baseline. Is the factory even running at the right speed? Because if the big picture is off, that's exactly where we need to start digging.
All right, so let's drill down to the next level of detail and see how this all connects. Now that we have a sense of the factory's overall health, it's time to put on our inspector hats. We're going to look at the individual products coming off the line, especially the ones that didn't make the cut.
You see, a number like 99% success can actually be pretty misleading. Is that 1% of failures all because of one temporary little glitch, or is it a nasty, persistent bug that's affecting a certain type of data? To figure that out, you have to track every single error, and importantly, you have to categorize it.
And this is where observability starts to feel like a superpower. Because not all errors are created equal, right? If a record is missing a field, that's just bad data. We log it, we skip it, we move on. But what if we can't connect to the database? That's a system timeout, and we should probably try again a few times. And some totally unexpected bug? Well, that needs a human, an engineer, to look at it like right now. You can't have this kind of smart response without detailed tracking.
So what's the big takeaway here? It's that the details tell the real story. A simple failure count just tells you that you have a problem. But detailed error tracking tells you what the problem is and how to fix it. And a lot of times, you can even fix it automatically. Okay, on to our third and final pattern. So we've checked the factory's overall health, and we've inspected the quality of the individual products. But there's one more piece of the puzzle, and it's a big one. Did we deliver on time? This is all about keeping our promises, to the business, to our customers. And in the tech world, we formalize these promises with something called an SLA, or a service level agreement. An SLA is what connects the technical performance we've been measuring directly to a real business outcome. This is how you build trust.
It turns system performance into a promise you can count on. And honestly, it's the ultimate measure of success. I mean, who cares if the job is 100% perfect if that critical report missed the 6 a.m. leadership meeting, right?
And just to be clear, we're not talking about vague hopes here. These are hard, measurable targets. The data must be available by 6 a.m. on the dot. If that job isn't done by 6:01 a.m., an alert fires. The error rate must be below 0.01%. Anything higher, and we've broken our promise. This makes sure our factory doesn't just work, but it delivers exactly as promised.
All right, let's pull all this together. We started with this silent, mysterious factory, a total black box. We had no idea what was happening on the inside, and we were always just reacting when something went catastrophically wrong.
But now, by applying these simple patterns, we've basically installed Windows, we've put in sensors, and we've set up a quality control station. That factory is not a mystery anymore. We've totally transformed it into a transparent, understandable, and manageable system. We literally turned that black box into a glass box.
So if you're going to remember anything, remember these 3 steps to get a transparent system. First, get the big picture with your job metrics to see how things are really doing overall. Second, find the flaws by tracking every single error to get to the root cause. And third, meet the deadline by monitoring your SLAs to make sure you're delivering on your promises.
And that really leaves us with one final big question. Every system, every job, every single line of code you run is constantly sending out signals. It's telling a story about its own health and its performance. The question isn't whether your systems are talking. They are. The real question is, are you actually listening?